In this video, we're going to talk about the most common form of a linear equation, which is slope-intercept form. Slope-intercept form follows y equals mx plus b, where m stands for the slope, which is the steepness of the line, and b stands for the y-intercept, which is the point where the line crosses the y-axis. And with these two pieces of information, I know how to specifically describe and also visualize a line on a graph. There's two things I need to know about this line. I need to know how steep it is. Is it going upward or downward? Is it a vertical line, a horizontal line? And how steep is that slope? That is the slope of the line. And then I also need to know, okay, where is this line at on the graph? And one way to tell where the line is at on the graph is to describe where it's crossing the y-axis. So the y-axis is this piece of information on my graph. So you can see that in these two lines on this graph, the blue line is crossing the y-axis right here at a positive 2. So it would have a b value of plus 2 because it's crossing the y-axis at a positive 2. The gray line is crossing the y-axis down here at about negative 3, so it would have a b value of minus 3. One reason why we use this form of a linear equation, because there are other forms to use, is that we use it when we can easily see the slope and the y-intercept. So as I look at both this blue and gray line, I can easily see where it's crossing the y-axis. We just described that. And I also can easily calculate the slope by using rise over run in this graph. So I would pick 2 points that fall on those crosshairs of that graph, and I would calculate the slope by finding its rise and run. As we look at these four linear equations, we are going to find the slope and the y-intercept of each linear equation. The slope is the number that's attached to that x variable because it is our rate of change. It talks about how I'm changing. If I'm getting bigger, going more positive, or if I'm getting smaller, more into the negatives. If my slope is positive or negative. So that is always the value that's attached to the x value. So in this first equation, my slope would be a positive 2. The y-intercept is that b value. So it's what's added or subtracted on at the end, and that's also describing about our graph where we're crossing the y-axis. So in this first example, I see that my y-intercept is a negative 5. Remember, with constants and numbers, the sign that's in front of it goes with it. So this is a negative 5, not positive. In this next example, I see that I have a negative sign in front of my x variable. So here, my slope would be a negative 1. Whenever I see a negative sign, that's really representing a negative 1. And then also, as I look at this equation, there's nothing added or subtracted on at the end. So it's really like saying plus 0. Now, we don't choose to write that in our linear equation because if I add 0 to something, it's not changing. So that simply just means that my graph is going to be crossing right here through the origin. So it's crossing that y-axis right through the origin. So maybe our line looks something like this, or maybe it looks something like this. So it would be where it's crossing right through that origin. In our next equation, our slope would be 1/2. So sometimes that slope may be a fraction. It may not always be a whole number. That is the m value of the equation. And the y-intercept here is a positive 2. So it's crossing that y-axis at positive 2. This last example is a little bit different type of an equation as well. I do not see an x variable in this equation, so there's no mx. Well, there really is, but this equation has just been simplified. This equation is really saying y equals 0x plus 10. Now, I don't choose to write the 0x because we all know throughout algebra principles that if I multiply by 0, that's going to be a value of 0, and also that if I add 0 to something, it's going to stay the same. So using that zero multiplication property and that additive identity to know that, hey, this equation does simplify to y equals 10. So this tells me that my slope of this equation is 0, which actually means that this y equals 10 is going to be a horizontal line, because remember, all horizontal lines have 0 slope. And then this 10 is my y-intercept, because that's what's added or subtracted on at the end, and it's a positive 10. So now we're going to use those same skills to now take that equation and graph it. So I'm going to start with my y-intercept of my equation, because that tells me where I'm at on the graph. So in this first equation, I have a y-intercept of positive 2. So I'm going to cross the y-axis at positive 2. Then I'm going to use the slope to rise and run. So my slope here is 3 over 4. So that is my rise over my run. So a positive rise tells me to go up. So I'm going to rise up 3 units. And a positive run tells me to go to the right. So then I'm going to run to the right 4 units as well. And I'm going to continue to do this until I run out of room on my graph, so I can make sure that this line is the most accurate as possible. Another form of the fraction 3/4 is negative 3 over negative 4, because those two negatives would cancel out, and that still is representing a positive 3/4. This also tells me that this line, I can stay in that consistent slope by rising down 3, because a negative rise tells me to go down, and to the left 4 units, because a negative run is telling me to go to the left. So I can also start from that y-intercept and go down 3 units and 4 to the left, and you'll see that I'm still directly in line with my blue line. And then I'm just going to connect each of these points with a line. Remember, lines continue on in both directions, so I am going to put those arrows on both of those. In this next example, remember this is really saying plus 0, so this equation here of this line is going to be crossing the y-axis right at the origin at 0. For my slope is negative 4. One way to write negative 4 as a fraction is negative 4 over 1. So that's going to help me visualize my rise and run. So that's telling me to go down 4 and 1 to the right. Down 4 and 1 to the right. Another way to write the form of negative 4 is 4 over negative 1, because 4 divided by negative 1 is still a negative 4. Remember, I cannot put the negative in both the numerator and denominator, because then those would cancel out and turn into a positive. So my slope is not positive. You'll see here that my slope is, in fact, a negative 4. So this second rise over run tells me that I can go up 4 and 1 to the left, and you'll see that I'll still be in line and have that constant rate of change. I have a consistent slope here. All right, we'll go through a couple more equations. In this next example, I have a y-intercept at negative 3. Remember, that sign that's in front of it goes with it. And then I have a slope of negative 2/3. There's 2 ways I can choose to write that slope. I can write it as negative 2 over positive 3, or positive 2 over negative 3. Those still both are representing a negative 2/3 slope. The first version of negative 2 over positive 3 is telling me to go down 2 and 3 to the right. So I'm going to do that as many times as I can. And then this second slope is telling me to go up 2 and 3 to the left. And you'll see that every single one of these points on my line is staying consistent with that slope. That's what it means to be a linear equation. I have a constant rate of change. All right, remember in this last equation, in order for that x variable to disappear, that slope is actually 0, that m value is 0, so this is really saying y equals 0x plus 5. So this is telling me I'm crossing the y-axis at a positive 5, and if I have 0 slope, that means I have a horizontal line.